So if we go to draw this triangle, start off with our ruler, and let's draw a line that is 4 centimeters long. So there's my line that's 4 centimeters in length. And then I need my 2 angles. So I need my protractor. So I can draw one angle that's 41 degrees. There's my 41 degree angle, my 4 centimeter line, and then I'm going to draw my other angle that's going to be 49 degrees. Here's my 49 degree angle. Compare your triangles. Do they look the same as each other? Yes or no? Yes, they do. So angle side angle works. They are going to be congruent. The last one that I have to draw is my side angle side. So it's 2 sides with a contained angle. So if we make this a 3 centimeter side, 105 degrees, and 2 centimeters. So let's start off with our 3 centimeter line. So draw a line for me that's 3 centimeters long. So here's my 3 centimeter line. Then I need a contained angle. So I need an angle of 105 degrees on either one of these. I don't care which one you pick, but you're going to draw a 105 degree angle. There's my 105 degrees. And now I need a line here that's 2 centimeters long. So I can either use my ruler and measure it out. Move this out of the way. Or I could use my compass and measure out a 2 centimeter line on my compass. And then use my compass to measure the 2 centimeters on here. Once I have this 2 centimeter line, I can join it to my vertex. And then compare with my neighbor. Did I draw the same triangle? Yes or no? Do they look the same? Yes. So if we go back to these pages, or to this page, when all 3 sides were the same, we drew the same triangles. When 2 angles and the contained side was the same, we drew the same triangles. And when 2 sides and the contained angle were the same, we drew the same triangles. This side here give me congruent triangles. The angle, 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 and the side, side angle gave me different possibilities. It doesn't work. You need to know these. You need to know the three sides, the side angle side, and the angle side angle. Those are my congruencies. So let's look at the examples. In each case, use the given information to determine if the triangles are congruent. If they are, state the congruency condition, whether it's a side, 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 side angle, side, or angle, side, angle. So if I look at question A, angle x, side, side, angle, angle. This is an angle, its contained side, and another angle. Are these going to be congruent? Yes or no? Yes. And the condition for congruency is the angle side angle. If I look at B, I have angle, 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 and angle. So I'm comparing three angles and saying that they are all equal to each other. Does that make the two triangles congruent? Is angle, angle, angle a test for congruency? No. So these are not congruent, or I don't have enough information to say that they are congruent. I need those side lengths. What are my conditions for C? Is that a test for congruency? Are they congruent? Yes. Okay, question D, I have two triangles here, so we're going to separate them. I have this side, this angle. What else do the two triangles have in common? The other side. So I could use tick marks to show that. So when I'm designating this, I have two sides, and this is the contained angle. So I have side, angle, side. Is this a test of congruency? Yes. So these two triangles are congruent. If we look at class example number 3, we have a parallelogram ABCD, and we are going to prove that the two triangles are congruent to each other. So if we have a parallelogram, that means that this side has to be parallel to this side. So AB is parallel to CD, and AD has to be parallel to BC. That's the definition of a parallelogram. Opposite sides are parallel. If I have two parallel sides and a transversal that falls in between, I create angles. I have two parallel lines, the transversal in between. I'm going to have alternate interior angles. And alternate interior angles are congruent. So I can write down that angle ABD, that's this angle right here. So we start ABD is equal to angle CDB. And the reason for that is because they are alternate angles. If I look at these two lines here, and again I have this transversal, so I'm going to have alternate interior angles between those two for the same reason. So now I can say that angle ADB is equal to angle CBD, because they are also alternate. Now, if I think back to my test for congruency, when I'm dealing with angles, there was two of them. There was angle, and side, angle, side. Is there a common side between these two triangles? This one right here, BD. So side BD is equal to BD because it's a shared side. Which gives me the condition of angle, side, angle. So then triangle ABD has to be congruent to triangle CDB. So let's look at class example number 4. The illustration shown represents the symbol for a communicator in a new TV space series. Use the information in the diagram to prove that the side length from A to D is the same as the side length from B to C. So this is what we're trying to prove, is that this line here is the same as this line here. So if I could prove that the triangles were the same, that would help. That would be a start. So what do I know? Well, if I pull this triangle out, let's label this triangle. A, C, D, this is 3 centimeters. And then if I take that other triangle out, B, D, C, this is 3 centimeters. This is the same side, so these two sides have to be the same. If I could somehow prove that these two angles were the same, I could then use side, angle, side. That's what we're going to try to see if we can figure out. Is there a way of proving that these two angles have to be the same? Well, let's look at this triangle right here. This is triangle FCD. What kind of triangle is this? How do you know?
It has 2 parallel sides.
So if these two sides are the same, it's isosceles, what else do I know about an isosceles triangle?
The 2 angles are opposite.
These two angles have to be the same. So let's call this angle X and angle X. So if these two angles are the same, what do I know about these two angles?
They should be the same too.
Why?
Some big word that I don't know yet.
Starts with an S,
No,
not symmetrical.
it's like
Mentary, mentary, something in between.
yeah. Symmetry.
Supplementary.
Supplementary.
And supplementary angles add up to. So then I can say through supplementary angles, angle ACD will be equal to angle BDC. And that's because angle DCF is equal to angle CDF because they're isosceles, or an isosceles triangle. So through supplementary angles, these two angles have to be the same. So then by side, angle, side, triangle ACD would be congruent to triangle BDC, which means side length AD has to equal BC. Those are your questions for homework.